Good morning, everyone. Today we're going to talk about how to solve a system by elimination. So we have solved a system by graphing, and if you remember, we had two lines and they intersected somewhere, usually, and that's the point we care about. We care about where do they intersect. So your solution to a system, because usually it will say solve the system, is going to be that point at which they intersect. And then we practiced doing substitution, which is where we plugged one equation into the other equation and our answer was still a coordinate. And then, so now I'm gonna show you a different way today, which is elimination, and our answer is still gonna be a coordinate. Remember, our answer should be the same regardless of how we figure it out. Okay, so that being said, we have our two lines, our two equations, and we're trying to find where they intersect. So I wrote some steps out here. The first thing we want to do is make one of the equation, or the first thing we want to do, is line them up. So see here how we have our x's, then we have our y's, then we have our equal signs. That's what we want. We want our x's, our y's, and then our equal signs. Now, it doesn't really matter so much if you have your x's first or your y's first, as long as they're lined up. All right, step number 2, multiply a number through so something will cancel out. I'm going to come back to this and talk about step 2 later on. Step 3, we're going to add going down. Okay, so here's what I want you to look for. I want you to line up X, Y, answer. And then what I want to happen is I like for people to always add. Now, there's a way to do this with subtracting, but I feel like so many times kids make careless mistakes that it's easier to just say, you know what, every single time I'm going to make this an adding problem. All right, and what I'm looking for is for something to cancel out. So if I were to add this right now going down, I would get 3x. Do you see here how if I have a positive y and a negative y, that's going to cancel out? That's what I want. I am going to only do this if something can cancel out. So something can cancel out right here. My y's are going to cancel out, and I'm going to get 9. All right, so what did we do? We lined everything up. We have our x, y's, answer. Something's going to cancel out, so we can proceed. We make this an adding problem. We add going down. That cancels out, and we add going down. And now we just have a normal equation we can solve for x. Divide both sides by 3. So x equals 3. Now, a lot of times we get carried away and we're in such a rush that we think we're finished. But remember, our answer needs to be a coordinate, okay? So we have the x value of the coordinate. We are not finished because we need an entire coordinate. But all we have to do is plug this value into either equation. Well, when I look at these two equations, the top equation to me looks easier. X plus y equals 7. My x is 3. 3 plus y equals 7. Subtract 3 from both sides, y equals 4. And that's the y value. So my coordinate is 3, 4. And that's where they intersect. So when I have these two lines, they're going to intersect at coordinate 3, 4. And I can check that. 3 plus 4 is 7. And 2 times 3 is 6. Minus 4 is 2. All right, so that all checks out. That is the solution to my system. All right, let's try another one down here. Okay, first thing is everything lined up. X, Y, answer, good. Now, is something going to cancel out? So if I were to continue moving on here, my X's would not cancel out. My Y's would cancel out. Okay, good. That means I can proceed. I don't have to do any skip step 2 yet. I'm going to go down to step 3. So I'm going to add. And I can do that because everything's lined up and this is going to end up canceling out. All right, so now I go ahead and add going down. 2x and a negative x gets me x. That's going to cancel out, and this is going to equal 5. Oh, so this one was even a little bit easier. So my answer is a coordinate. I only have this here, this box, so I know don't forget to go back and fill this whole thing in. Okay, so my x is 5. I'm going to fill it into either equation. Well, this one looks a little bit easier because I don't have a coefficient here. So I'm going to go ahead and say negative x plus 4y equals 3. I'm going to plug my 5 into here. Negative 5 plus 4y equals 3. Add my 5 to both sides. 4y equals 8. and y equals 2. Okay, now I can double check that. Negative 5 plus 8 equals 3. That's right. Plug it in here. 10. 2 times 5 would be 10. Minus 4 times 2 is 8 equals 2. So that checks out. The solution to my system is 5, 2. All right, let's go on to this one. So this one, you might be able to do this one without me. You might want to just pause the camera and see if you can see what's going on here. But I will keep working in case you're not sure. So once again, everything is lined up fine. This is gonna cancel out, so I can keep going. I'm gonna make this an adding problem. That cancels out. I have 5y equals negative 5, because I just add everything going down. Divide both sides by 5, so y equals negative 1. I now have the y value is negative 1. So I'm going to plug this into either equation. It doesn't really matter which one in this case. I'm going to go ahead, plug it into the bottom. So I have negative 2x plus 2y equals negative 6. I'm going to plug my negative into the y spot. Negative 2x plus 2 times negative 1 equals negative 6. Multiply that. Negative 2x minus 2 equals negative 6. And now I'm just solving my equation. Add 2 to both sides. Negative 2x equals negative 4. Divide by 2. Negative 2, sorry. X equals 2. Now I kind of did that really quickly with my negatives there, so I do want to double check this. I'm going to plug a 2 in here. 2 times 2 is 4. Negative 1 times 3 is negative 3. 4 minus 3 is 1. Looks good. Remember, it does need to work for both equations. 2 times negative 2 is negative 4. Negative 1 times negative 2 is negative 2. Negative 4 and negative 2 is negative 6. So we're in good shape there. All right, I want to show you what's going to happen. Remember at the beginning when we were going through the instructions, I said I'm going to kind of skip over step number 2. Well, I'm going to explain this right now. Okay, so let's start off like we would normally. All right, we have everything lined up. X, Y, answer. We look like we're in good shape. But now when I look here, if I make this an adding problem, which I am going to do, nothing's going to cancel out because I'm going to get a 3x and a 5y, and I need something to cancel out. So what I'm going to do is I'm going to say, well, what do I want? And if I look here, what do I wish this was right here? If this was a negative 2x, that would be perfect. So I'm going to go ahead and I'm going to multiply this entire top equation by negative 2. And now when I do that, to distribute it, now when I do that, I get negative 2x minus 6y equals negative 14. I'm just going to check my signs real quick. Negative 2, negative 6, negative 14. On the bottom, 2x. I didn't do anything to the bottom, so I leave that all the same, but I wanted to line them up. Okay, now I can go ahead. So what we just did was step 2. We multiply through a number, so something will cancel out. We multiplied this entire equation by negative 2 so that my x's would cancel out. All right, so now I can make this an adding problem. My x's are going to cancel out, which is what I wanted. And now I have negative 4y equals negative 8. Divide both sides by negative 4. And y equals 2. All right, remember, my answer is going to be a coordinate. That's the y value. I'm going to plug it in. I can plug it into either equation. Okay, so why don't we just plug it into the top? That seems like an easier one to plug it into. X plus 3y equals 7. We said x is 2. So x plus 3 times 2, 7. X plus 6 equals 7. X equals 1. And I'm going to double check this. 1 plus 2 times 3 is 6. 1 plus 6 is 7. That works. 2 times 1 is 2. Plus 4 is 6. So that works. All right. So let's look at this guy down here. If we look here, once again, everything is lined up, which is great. I notice that nothing is going to cancel out. So I could, if I wanted, if I looked here, I could say, well, I want them to both be, one to be positive 10 and one to be negative 10, and that would be fine. But then I would have to multiply both. It doesn't mean you can't do it. It just means it's making it a little trickier. Here, here I can look here and say, well, I would just wish this numerator was a negative 2 because then those would cancel out. So I'm going to multiply this entire numerator by negative 2. All right, so I have negative 2x to distribute minus 4y equals negative 8. And my bottom equation, I'm going to leave the same. All right, make sure I distributed that right. Negative 2, negative 4, negative 8. And now I'm going to add. I always like to make it adding. I'm going to add, and that's going to cancel out. So I have negative 9y equals negative 9. So y, divide both sides by negative 9. Y equals 1. Okay, so now I'm going to plug it in. Well, x plus 2y equals 4. We said that y was 1. X plus 2 times 1 equals 4. X plus 2 equals 4. So we're going to say x is 2. Sorry. Now, like I said, once we start doing this really fast, that's when checking is super helpful. So 2, I plug it in here. 2 plus 1 times 2 is 2. 2 plus 2 is 4. Plug it in, that works. 2 times 2 is 4. Minus 5 times 1 is 5. Equals negative 1. So that's good to go. All right, look at this problem down here. This one is a tiny bit different. If you notice here, they don't line up. All right, no big deal. We just have to get them to line up. So what I'm going to do is I'm going to go ahead and I'm going to put the x in front. And I can't just move it, right? I have to say, well, what would I do to both sides? I would subtract x. So when I rewrite this, I'm going to say, okay, negative x, because I'm subtracting x from both sides, and I want my x to be first so it lines up here. Negative x plus y equals 13. Okay, I'm just going to kind of section that off. Now my bottom, I didn't do anything to, so I'm just going to say 2x plus 7y equals 10. Now I will occasionally get students say, but Miss Knight, this top equation is not in standard form because you have a negative over here. That's okay, because right now I'm not too worried. It doesn't have to actually be in standard form. I could have my y's, then my x's. I just need everything to line up. Okay? So now I'm going to take a look at this, and does something cancel out? It does not. So what could I multiply this by? Well, I really wish this was a negative 2 instead of negative 1. So I'm going to multiply this entire thing by 2, and I'll rewrite it down here. Okay, so when I distribute the 2, I get negative 2x plus 2y equals 26. And my bottom, I did not do anything to, so I'm going to leave that the same. I know I'm going to be tight on room here. Okay, so I add going down. That's going to cancel out. I get 9y equals 36. Y equals 36 divided by 9 is 4. Okay, so I'm going to put my answer over here. Now this is the y value, so I have to put this in the y spot. Okay, I'm going to plug it in to this top one. So this says y equals x plus 13. I have to fill this into the y. So 4 equals x plus 13. Subtract 13 from both sides. Negative 9 equals x. All right, I'm going to check that out. Negative 9 plus 13 is 4. Here, my x is negative 9, so I have negative 18, 28, and I get 10. So we're good to go. All right, I just have 2 more problems I wanted to show, or one more, no problem. All right, so on this problem here, you have your x, your y's, and your answer. Once again, nothing's going to cancel out. Now, I do want to, well, I'll point it out after. Okay, so what do I want to do? I'm going to multiply, let's say the numerator, not numerator, let's say I'm going, oh goodness, I wish this was a negative 4. Well, that's easy to get to. If I multiply this whole thing by a negative 2, then that will be a positive 4, and a negative 4y will cancel out. Okay, so I'm going to distribute that. Now my numbers are starting to get a little big. So I have negative 16 plus, negative 16x plus 4y equals 16. My denominator, I keep saying denominator, my bottom equation. Okay, I'm going to add. That cancels out, and I have, or that doesn't cancel out, sorry. I subtract that, and I have negative 11x. These cancel out, equals, oh my gosh, don't tell me this is going to be crazy, 733. All right, divide both sides by negative 11. X equals negative 3. All right, then I'm going to plug that in. I can plug it into either equation. Let's go with the bottom one. 5x minus 4y equals 17. Plug that into here. 5 times negative 3 minus 4y equals 17. Negative 15 minus 4y, 17. Add 15 to both sides. And that's negative 8. So I have, oops, I forgot to write it down. So remember, my answer is a coordinate, my x value is negative 3, and my y value is negative 8. The one thing that I did want to refresh your memory on, or just let you know, is occasionally, and I'm totally making this up, oh, I need a y in there. Something like this. We're not going to do this whole problem, but what I want to show you is if you look here and you say, wait a second, oh my gosh, Miss Knight, could I just like maybe I could do subtraction method, which is a method, but what I would do in this case, because you're looking here and you're saying, oh, I just wish that this was a negative or this was a negative, you could multiply the entire thing by negative 1. And then you would have a negative x minus y equals negative 5, and you would have x minus 10y equals 2, and so then you would say, okay, your x's cancel out. So you can just multiply one row by a negative if that's all it takes to get something to cancel out. Okay? All right, you guys have a good day. Bye.